Hello students, I hope you are all doing good and we are here for the discussion of JEE Mock Test 12. So let us begin with this question. This question says that the velocity displacement graph of a particle is shown in this figure, okay? And we have to figure out the acceleration displacement graph. So in order to find the answer of this question, we first of all will construct the equation of velocity and displacement, which will be, I think you guys can understand this value. Now, in order to find out the equation of acceleration and position or displacement, we can use this equation, right? V dv by dx. So basically, the value of dv by dx will be equal to minus of v naught by x naught, right? You can observe it from here. And if we put the value of v and dv in this equation, we will get the value of acceleration as v naught by x naught with a negative sign times minus v naught by x naught times x plus v naught, right? So if you rearrange this equation, solve this equation further, you will get v naught by x naught square times x minus, sorry, there is this minus v naught square by x naught. So from the look of this equation, what we are observing is that here a is proportional to x and the slope is positive with a negative intercept. So I think option C depicts the correct answer. Okay, with respect to this equation, option C depicts the correct answer. So let's see the next question. This next question says that consider a uniform wire of mass m, length L. It is bent into a semicircle. Its moment of inertia about a line passing through the plane of wire passing through the center is. So basically, the moment of inertia of such a semicircular wire will be equal to mr square, right? And in this case, we just need to figure out that what will be the value of r. So we know that the circumference of this semicircle is pi r, and that must be equal to L, which is the length of wire. Therefore, r is L by pi, right? And therefore, if I replace the value of this r into the value of moment of inertia, we will be getting ml square upon pi square. So I think option A becomes the correct answer. So let us move on to this next question, which says that the function of time representing a simple harmonic motion with a period of pi by omega is, okay, pi by omega. Now, of all of these options, option C is going to be the correct answer. Why? Because time period is represented as 2 pi by omega, and you can locate that the value of omega for this motion is 2 omega, right? So therefore 2 pi by 2 omega will result in pi by omega, right? All the other options are not going to have the same value of time period, as they are either the combinations of the SHM, different SHM, or we have to modify them. Okay, the equation of other SHMs will not result in the time period as being asked in the question. So let's observe our next question. This question says that consider a sample of oxygen behaving as an like an ideal gas at 300 Kelvin. So we have to figure out that what is the ratio of root mean square RMS and average velocity of gas molecule. Okay, molecular weight and R is given, but I presume that it is not needed. So the expression of VRMS is root 3 RT divided by M, and the expression of V average is under root 8 RT divided by pi m, right? So the question is basically asking that what is the ratio of VRMS to V average. So VRMS to V average is under root 3 pi by 8. Option B becomes the correct answer. So let us move on to this next question. It says that if the angular velocity of Earth's spin is increased such that bodies at equator starts floating, the duration of the day would approximately be. So in this question, try to observe that if the bodies have to start floating in the upward direction, which will mean that the centripetal force becomes equal to mg, right? So m omega square r should be equal to mg. From here, we can say that the value of omega is going to be g by r whole root, okay? And therefore, the time period or time duration should be equal to 2 pi by omega. So that should be 2 pi root of r divided by g. So if we put in the value of R and G, R is given here and the value of G is to be taken as 10. So if we put in these values, we will get the time period approximately equal to 84 minutes. If you calculate it, you will get option C as the correct answer. So let's observe the next question. It says that a particle of mass m moves in a circular orbit under a central potential field given by this value, where c is a positive constant. So question says that what is the correct radius velocity graph of particles motion. Okay, so in order to solve this question, first of all you need to understand that if you want to figure out the force due to a potential field, that force will be given by this equation, right? F equals minus du by dr. So if you differentiate the given equation, you are going to end up with plus c times differentiation of 1 by r, or equal to minus c divided by r square, right? This is your force. So what would be the magnitude of force? Magnitude of force will be c divided by r square, and that should be equal to mv square by r, right? So if you solve it further, you are going to end up with this value that v square is inversely proportional to r, and therefore the graph between v square and r, yeah, v and r should look like this parabolic graph. Okay, so this was question number 6. Let's move on to our next question. So question number 7 says that which of these following statements are correct. Okay, let's observe them one by one. Electric monopoles do not exist. We have to figure out the correct answer. And there is a problem with this statement of this question. Electric monopoles do not exist. No, that is incorrect. They do exist. Positive and negative charges are the electric monopoles. Remaining part of this statement says, whereas magnetic monopole exist. That is incorrect, because magnetic monopoles, that is single north, single south poles, does not exist. So option A is the, statement A is the incorrect answer. Statement B says magnetic field lines due to solenoid at its end and outside cannot be completely straight and confined. Okay, so this is incorrect because the magnetic field lines near the end and inside the solenoid are absolutely straight, and they are confined within the solenoid body. Okay, so statement B is also incorrect. Option statement C says that magnetic field lines are completely confined within a toroid. That is a completely correct statement. Statement D, magnetic field lines inside a bar magnet are not parallel. No, they are very, very parallel, because a bar magnet is a type of magnet which has straight edges. Okay, it is a slender body which has a straight edges. So the magnetic field lines obviously are present parallel to the length of the magnet. So statement D is also incorrect. And statement E says that x equal to minus 1 is a condition for a perfect diamagnetic material. Perfect diamagnetic material where x is its magnetic susceptibility. This statement is correct because if we think about the relative permeability, then it will be equal to 0 for x equal to minus 1, and this happens for superconductors. Okay, so statement E is absolutely correct, and therefore option C becomes the correct answer. So let's move on to next question. Question number 8 says that for an adiabatic expansion of an ideal gas, the fractional change in its pressure is equal to, where gamma is the ratio of specific heats. So for an adiabatic process, we know that PV to the power gamma is constant. And therefore, if we differentiate this equation, we will get the value of dp by dv equals minus gamma divided by v. So this is something which we already learned in our regular sessions. Okay. So question is asking the fractional change in the pressure, which will be represented by dp by p, and with a little rearrangement, you will get this value, right? So minus gamma times dv by v is the correct answer, and option C seems to be the correct answer. So let us move forward and observe this question. It says that the angular momentum of a planet of mass m moving around the sun in an elliptical orbit is L vector. The magnitude of aerial velocity of this planet is. So uh, I think this is based upon Kepler's second law of motion, and the correct answer is L divided by 2m. But let us observe how to prove it. Say, for example, a planet is moving in an elliptical orbit. So, for a very small distance dr, the between these two positions of a planet, we can say velocity vector is in this direction. We can say that its value of dr, just a second, its area can be simply represented as half times the cross product of r and v. Okay, so this is your area vector for this very small triangular portion covered by the particle while displacing through a very small dr distance. So this is your area velocity, and for larger distance you can consider a vector as the magnitude of a vector as this quantity. So question basically is asking that what is dA by dt equal to. So that should be equal to half times, sorry, uh, there is a small mistake. This small distance is v into dt, right? Distance covered in a small duration of time, and this is r vector. So we have got area vector equal to r vector cross v vector into dt, right? So what is dA by dt? dA by dt will be represented by r cross v. Okay, and if we multiply and divide with m, the numerator will be equal to the magnitude of angular momentum, which must be divided by the mass of twice the mass of the planet. So dA by dt is L vector magnitude of L divided by twice of mass of the planet. Okay. So question number 10 says that a plane electromagnetic wave propagating along y direction can have the following pair of electric field and magnetic field components. Okay. So in this question, you should understand that the relation between the direction of propagation and the direction of electric field and magnetic field is given by this equation. C cap equals E cap cross B cap. And also we know that the magnitude of magnetic field equals the magnitude of electric field divided by speed of light. Right? So these two equation governs the the kinematics of, sorry, my bad, the mechanics of electromagnetic wave, right? So in this case, it is stated that the direction of propagation of this light or electromagnetic wave is y direction. So we have y cap here. Therefore, E cap cross B cap should have the direction of y cap. So the direction of E and B should be either in this manner or in this manner. So electric and magnetic field pair must be along x and z. So option D seems here the correct answer for this question. Now moving forward. So this next question says that a proton and an alpha particle having kinetic energies Kp and K alpha respectively enter into magnetic field at right angle. Okay? Their motion is at 90 degree with the magnetic field. The ratio of radii of trajectory of proton to that of alpha particle is 2 to 1. The question is asking that what is the ratio of kinetic energy of proton to the alpha particle. So in this question, we need to first of all understand that the radius of motion or radius of their trajectory is represented by this equation mv divided by qb, right? Which is also equal to the momentum divided by qb. Since magnetic field is same for both of them, we can conveniently say that radius of proton upon radius of alpha particle will be given by p, that is momentum for proton upon charge of proton into magnetic field, charge of proton into magnetic field multiplied by charge of an alpha particle magnetic field divided by the momentum of alpha particle. And the ratio of their trajectories is given as 2 to 1, right? So from here, we can figure out the ratios of their momentums. So momentum of proton to the alpha particle is equal to 2 times the charge of proton upon charge of alpha. And I think you guys know that this ratio is half. So the ratio of their momentums will be equal to 1. And hence, the kinetic energy ratio will be equal to momentum of proton upon 2 times the mass of proton and 2 times mass of alpha divided by momentum of alpha. So since we know that momentum of proton to alpha is 1, therefore this ratio will be m alpha upon mp, and we know that this is equal to 4. So answer is 4 to 1, option D. So moving on to the next question. This question says that the speed of electrons in a scanning microscope is 1 times 10 to the power 7 meters per second. If the protons having the same speed are used instead of electrons, then resolving power of scanning proton microscope will be changed by a factor of. Okay. So in this case, we need to first of all understand that the resolving power of any instrument is equal to is proportional to the inverse of its lambda, and the value of lambda can be figured out by using the relation of de Broglie wavelength, that is h divided by mv, right? So the inverse of lambda will become mv upon h. Now in this case, h is a universal constant, and the question says that speed of both electron and proton are same. So therefore, resolving power in this case should become proportional to the mass of the particle, or resolving power of protons to the resolving power of electron should be equal to mass of proton to the mass of electron, and this is 1837 times to the 1. Okay, so the answer of this question becomes option D. So next question says that the decay of proton to neutron is, option A says, always possible as it is associated only with beta positive decay, possible only inside nucleus, this seems correct, not possible but neutron to proton conversion is possible, somewhat questionable, and not possible, actually this statement is also wrong, not possible as proton mass is less than the neutron mass. No, this is not the criteria. So the only correct answer, the most appropriate answer for this question is option B. Okay, that a proton to neutron decay is only possible inside the nucleus. Why? Because uh, if you look at the mass of proton, mass of an isolated proton and mass of isolated neutron, then the mass of isolated neutron is always greater. So in case when a proton is completely isolated, it cannot convert into neutron because of the less value of mass associated with the mass of proton, right? So proton's mass is less, therefore it cannot convert into neutron if they are isolated. But in case of nucleus, apart from proton, single proton, there are other greater number of protons and neutrons present, and therefore in that case the beta positive decay happens by decreasing the overall potential energy of the entire nucleus, not the proton, but for the entire nucleus. That is why this kind of decay is only possible inside the nucleus. So let's observe the next question. This question says that the time taken for the magnetic energy to reach 25% of its maximum value when a solenoid of resistance R, inductance L is connected to the battery is. So in this case, uh, in case of such a solenoid, we can say that the magnetic energy is going to change due to the current which is present, which is flowing through the solenoid, and the magnetic energy inside the solenoid is represented by this equation, right? Half Li square. So we can say that the final energy when some current I is flowing inside the solenoid is one fourth, that is 25%, one fourth the initial amount of energy, or maximum amount of energy, not initial, my bad, maximum amount of energy. So when we sort this out, we will figure out that the value of electric current will be equal to half of the maximum value of electric current, right? Now, during the charging process of a solenoid, charging means during the process, during the part when the solenoid is experiencing an increment in its current, the equation of current with respect to time is given by this value, right? E divided by tau. Tau is your time constant. So if I put the value of I here and the value of tau, and the value of tau is L by R, right? So if we put these values and solve it together, we are going to end up with time as L by R natural log 2, right? Option A becomes your correct answer. So let's observe the next. So let us observe this question. In this case, states that three rays of light, namely red, green, and blue, are incident on the face PQ at right angle prism PQR, as shown in the figure. The refractive indices of the material of prism for red, green, blue wavelengths are 1.27, 1.42, and 1.49 respectively. The question asks us that the color of rays emerging out of phase PR is. Okay, so which one of these colors are going to emerge out of phase PR? So in order to attempt this question, you need to first of all understand that when these rays enters the prism, they are going to move undeviated until they reach surface or face PR, okay, because they enters at the angle of 90 degree. And for each of them, this angle theta will be equal to 45 degree, right? So any ray which has the value of critical angle more than this theta, that is 45 degree, will emerge out of the surface PR, and whichever light ray or wavelength or color which have theta c less than theta will not emerge out, right? So first of all, let's understand that what should be the value of refractive index for that light ray for which the critical angle is 45 degree, right? So you guys can understand, if you solve this equation by putting theta equal to 45 degree, you will get the value of mu as under root 2, okay? So the value of root 2 is also 1.414. So any light ray which has the value of refractive index less than the root 2 will have theta, will have its critical angle theta more than 45 degrees, right? So we should look into those light rays which have wavelength less than, refractive index less than under root 2. And I think only red color satisfies this condition. So red is the only light ray which is going to emerge out of this prism from the face PR. So let us move forward. Next question says that an ideal gas cylinder is separated by a piston in such a way that entropy of one part is S1 and that of the other part is S2. Given that S1 is more than S2, if the piston is removed, then the total entropy of the system will be. Okay. So in this case, we should understand that if there is a cylinder present, right, and it is separated by a piston. Separated by a piston means there are two chambers in this ideal cylinder. Ideal cylinder will be the type of cylinder which is forming an isolated system. It is neither going to exchange mass or energy from the outside, from the surrounding, right? So entropy of an isolated system never changes, okay? And therefore, if you are removing the piston from the system, then in that case, the entropy of system will not change. Hence, the total entropy will remain the same. Okay, so I think option A is going to be the correct answer. So jumping on to the next question. Here it says that the correct relation between alpha, that is the ratio of collector current to the emitter current, alpha is collector current to the emitter current, and beta, which is the ratio of collector current to the base current, right? This is emitter current, collector current to the base current. So we have to figure out the ratio, the relation between these values. Now, we also know that the emitter current is equal to the base current plus the collector current. So if we replace the value of IE and IB from the above equations, we are going to get IC by alpha equals IC by beta plus IC, right? So we will get 1 by alpha equals 1 by beta plus 1, right? And if you solve it out, you will get alpha equals beta divided by 1 plus beta. So option C becomes your correct answer. So let's observe the next question here. This question says that in a series LCR circuit, the inductive reactance XL is 10 ohms, the capacitive reactance XC is 4 ohms, and the resistance in the circuit is 6. Okay. The question is asking that what is the power factor? So power factor in a circuit is always represented by this formula cos phi, which is equal to R by Z, where Z is impedance, which is root of R square plus XL minus XC whole square. So all the values are given, right? All the values are given in this question. We just need to figure out the value of Z and then put it here in the formula of cos phi. So the power factor finally, after doing all these calculations, will come out to be as here the value of Z will be 6 root 2 and the value of resistance is 6. So when you put the value of R as 6 and Z as 6 root 2, the value of power factor will be option D, that is 1 by root 2. So moving to the next question, which says that an object of mass m1 collides elastically with another object of mass m2, which is at rest. After collision, the objects move with equal speeds in opposite direction. The ratio of masses m2 to m1 is. Okay. So, in order to find out the answer, here we have to obviously conserve the momentum. There are two equations: conservation of momentum and the equation of uh, uh, coefficient of restitution. Okay, so let's say that initially m1 mass is moving with speed u, m2 mass initially was at rest, and after the collision they are moving with speed v in opposite direction. So conserving momentum will give us that m1 into u, initial momentum, considering rightward direction is positive, m1 into u equals minus m1v plus m2 into v. Okay, so if I divide m1 in this entire equation, I will get u equals minus v. If I take also v as common in the RHS, I will get v common and minus 1 plus m2 by m1, right? So this becomes our first relation. The second relation will be obtained from the equation or relation of coefficient of restitution, which is v2 minus v1 divided by u1 minus u2, right? So that is 2v by u, and that's equal to 1 because the collision was deemed as elastic. So from here we can say that v is equal to u by 2. So this becomes our second relation. So from first and second relation, we are going to get what? We are going to get u equals u by 2 times minus 1 plus m2 by m1. So when you solve it, finally you are going to get the value of m2 by m1 as C, right? So option A becomes your correct answer. So let's observe our next question. This question says that a solid cylinder of mass m is wrapped with an inextensible light string and is placed on a rough inclined plane as shown in the figure. The frictional force acting between the cylinder and the inclined plane is, if the coefficient of static friction is this value, take the coefficient of kinetic friction and coefficient of static friction equal to each other, and the coefficient of static friction is given as again 0.4. So basically the question is asking us that what will be the value of frictional force acting on the cylinder. So in order to understand or solve this question, we need to first of all figure out that what will be the condition at the location where the cylinder and inclined plane are touching each other. Okay, what will be the condition? Whether we have a static condition or a kinetic condition at this location. So in order to do that, let's consider the condition of equilibrium. Okay, so in order to assess the situation, let us consider that cylinder is going to be at rest. So if the cylinder has to be at rest, then what should be the value of T and F in order to keep the cylinder at rest? Okay, so we are going to solve this by first of all assuming the static condition. So in this case, we can say if the condition is of static equilibrium, then T plus F, look at the direction of frictional force here. And please observe that if direction of frictional force in this figure is not correct, then the value of frictional force will simply come out to be as negative, right? So we don't have to be fearful about the direction of frictional force. So observe T plus F should be equal to mg sine theta, right? M is the mass of the cylinder. So this is mg sine theta in this direction, and here we have mg cos theta. Okay, component of mg forces are shown here, theta being 60 degree. So this becomes our first equation. Second equation should be from the consideration of torque about the center or about the center axis. Okay, so in this case, if we think about the torque of tension force and frictional force, then we can say that they are e both opposite to each other. And in this case, for static condition, the rotational acceleration or angular acceleration will be equal to 0. So this becomes our second condition. Okay? So from second, we can observe that T is equal to F. We will get T is equal to F here. And if we put it here in the first equation, we will get T equal to F equal to, sorry, T equal to F equal to mg sine theta divided by 2. Okay, mg sine theta divided by 2. So what we are observing is that the value of frictional force should be equal to mg sine theta by 2 if we want to keep the cylinder stationary. Okay, now since both coefficient of friction for kinetic and static are same, we can say that for the limiting value of static friction, which has the value of mg cos mu mg cos theta, right? Which one among these two is greater, right? So if you observe and compare these two values, you will get the value of limiting friction as 0.4 multiplied by mg multiplied by cos theta. Cos theta cos 60, theta is 60 degree. So cos 60 is half. So we are going to get 0.2 times of mg, right? Whereas the value of mg sine theta divided by 2 will be equal to root 3 by 4 times mg. So clearly from these two values, from the comparison, we can say that the value of friction required to keep the body in equilibrium in static condition is greater, required value is greater than the available value, that is the limiting friction, right? So in this case, since limiting friction is smaller than the required value of friction to keep the cylinder at rest, the cylinder cannot remain at rest. Okay, the cylinder cannot remain at rest, and therefore it is going to slip in downward direction, or it will slip in upward direction, whichever the case be, depending upon the value of t. But it will not be in static condition. So if it is not in static condition, then the value of friction should be of kinetic type, and that must be equal to mu mg cos theta, which is equal to 0.2 times mg, or mg divided by 5. So this is your answer. And by the look of it, I think option C appears as the correct answer. So let's look at the next question. This next question says that the radius of a sphere is measured to be 7.50 plus minus 0.85 centimeter. Suppose the percentage error in its volume is x, then the value of x is. Okay, we have to figure out the value of x. So in order to write down the answer of this equation, answer of this question, let us consider the formula for volume of a sphere. Okay, so volume of a sphere is represented by this formula. So if we differentiate this equation, we will get dv equal to 4 pi r square. So what will be the value of dv by v? That will be equal to, uh, there is dr here as well. That will be equal to 3 times of dr by r. Okay, dr by r. So in this case, we want to figure out that what is the percentage error in measurement of its volume. So if we multiply this fraction with 100, we'll get the percentage error. So what is dr? Dr is the error in measurement of radius r, which is given as 0.85 divided by 7.5, which is r, times 100%. So if you solve it further, you are going to get the final answer is 34%. Okay? So let's observe the next question. It says that consider a 72 centimeters long wire AB as shown in the figure. Galvanometer jockey is placed at P on AB at a distance x centimeters from A. Galvanometer shows zero deflection. The question is asking the value of A to the nearest integer. So let us consider the let us observe that what will be the value of PB. You can pretty much understand that if AB is 72 centimeters long, PB should be 72 minus x. And now this becomes the case of a balanced Wheatstone bridge in a meter bridge condition. So we will get 12 by 6 equal to x by 72 minus x. Okay. And if we solve it further, we are going to end up with the value of x as 48 centimeters. Okay. So let's observe the next question. This question says that an infinite number of point charges, each carrying 1 microcoulomb charge, are placed along the y-axis at y equal to 1, 2, 4, 8, and so on meters. The total force on 1 coulomb point charge which is placed at the origin is x times 10 to the power 3 newtons, and we have to figure out the value of x. So this is basically a classical question in which we will say that the net force on the charge present on the on the origin is going to be equal to k times q times capital Q divided by d square, summation of d square, right? So we will get 1 by d1 square plus 1 by d2 square and so on, right? So the value of k is 9 times 10 to the power 9. The value of charge placed on each of the y coordinates is 1 microcoulomb, so that's 10 to the power minus 6. Capital Q, that is charge on the origin, is plus 1, right? And we have d1 as 1, d2 as 2, d3 as 4, and so on, right? So here we are observing that we have an infinite series. The value of A is 1 and the value of R is 1 by 4. So we've got 9 times 10 to the power 3 times 1 minus A divided by 1 minus R. R is 1 by 4, right? So solving this, we will get the value as 12 times 10 to the power 3, okay, Newton. So the answer is 12. So let's observe our next question. This question says that a TV transmission tower antenna is at height of 20 meters. Okay. Suppose that receiving antenna is at ground level and is at height of 5 meter. The increase in antenna range in case 2 relative to case 1 is n%. We have to figure out the value of n. So basically what question is saying is that in first scenario, if this is your antenna, then receiver is present at ground level. Okay, so the range of the antenna is somewhat here. In the second case, the receiver is now mounted on a height of 5 meters. So obviously the range of received signal is going to increase, right? So question is asking that what is the percentage change in both of these two cases. Okay, so we know that the formula for range of TV signal is given by root of 2r into h, r being the radius of earth, h is the height of antenna. Okay, so in first case the value of range r is root 2 capital R times 20. In the second case, the value of range is root 2 capital R times 20 plus the other range due to the height of receiver, that is 2 capital R times 5. So what is percentage change in the range? That will be represented by R2 minus R1 divided by R1 times 100%, right? So when you put these values, you will understand, you will observe that root 2 into capital R will eliminate from both numerator and denominator. So we are going to be left with root 20 plus root 5, that is R2, minus R1. R1 was root 20 divided by R1, that is root 20 times 100%. So when you sort this out, when you solve it, you are going to end up with 50%. So answer is 50%. So next question says that two wires of same length and thickness, they are of same length and thickness, having specific resistance 6 ohm centimeter and 3 ohm centimeter respectively are connected in parallel. Okay, so resistivities are given. Question is asking that what is the effective resistivity to the nearest integer. So we know that the effective resistance or equivalent resistance in case of parallel combination is given by this equation, as well as the value of resistance is resistivity times L upon A. Now L by A value is common for both the wires, therefore we can say that if we replace the value of R equivalent with effective or equivalent rho, that should be equal to rho 1 rho 2 divided by rho 1 plus rho 2, right? All the values of L and A are going to eliminate in the entire equation between numerator and denominator as well as in the LHS. Okay, all the values are going to get eliminated. So finally, we are going to end up with this equation. And if we put 6 and 3 as the values of rho 1 and rho 2, then we will get 2 in the RHS. Okay, this value is going to be 2 ohm centimeter. But in the LHS, please remember, please observe that in order to find out rho equivalent, you should understand that when they are connected in parallel, we effectively have kept the length of the wires as same, but have doubled the area. So that factor in the denominator of LHS should also be there, right? And if we cross multiply it over here, we will finally be getting the equivalent or effective value of rho as 4 ohm centimeter. Your answer is 4. Okay, so let us move to our next question. This question says that the ball of mass 4 kg moving with velocity of 10 meters per second collides with a spring of length 8 meters and a force constant of 100 Newton per meter. Length of the compressed spring is x in meters, and we have to figure out the value of x to the nearest integer. So we can simply say that in this question, the entire kinetic energy of the ball is going to transfer into the spring and will be stored in the form of potential energy, right? So we want to find out the length of the spring, compressed spring, for which we need to figure out that how much compression has occurred. So if we want to find out the value of m, that will turn out to be as v times root of m by k, right? Putting all these values of v is 10, m is 4, and the value of k is 100. So by putting all these values, we are going to get the value of compression, that is y as 2 meters. Okay, so compression का amount कितना हुआ? What is the amount of compression? 2 meter, and therefore the final length will be original length minus compression, that is 8 minus 2 or 6 meters. So your final answer is 6 meters. Okay, so let's observe our next question. This question says that a galaxy is moving away from Earth at a speed of 286 kilometers per second. Shift in the wavelength of a red line at 630 nanometer is x into 10 to the power minus 10 meters, and we have to figure out the value of x. So this is basically a question which is from Doppler's effect of light, or the idea of redshift, and the formula which we have to use here is this formula. Okay, that, or you know this formula in a different manner, that speed of object upon speed of light is change in the wavelength of light upon the original wavelength. Okay, so we know everything and we need to figure out the value of delta lambda here, right? So delta lambda will be equal to v by c times lambda, And by putting all the values in this equation, we will get 6 times 10 to the power minus 10 meters as our answer. So your answer is 6. So let's observe the next question. This question says that a typical output characteristic curve for a transistor working in common emitter configuration is shown in this figure. Okay, so the values are shown here. The estimated current gain from the figure is, question is asking that how much is the estimated current gain. So simply we can say that the current gain, that is beta, is basically represented as change in the collector current divided by change in the base current. Okay, so this is our formula. So as you can observe that each time a step is increased, we can say that change in the collector current is going to be equal to 4 minus 2 or 6 minus 4 or 8 minus 6, that is 2 microampere, so 10 to the power minus 3, divided by change in the base current during the same period, right? So that is 10 times 10 to the power minus 6 ampere. This ratio will give you 200 as the value of beta. So estimated current gain in this figure is 200. So let us observe our next question. So next question says that consider a water tank as shown in the figure. Its cross-sectional area is 0.4 meters square. Tank has an opening B near the bottom whose cross-sectional area is 1 centimeter square. A load of 24 kg is applied on water at the top when height of water level is 40 centimeter above the bottom. Velocity of water coming out of the opening B is V meters per second. We have to figure out the value of V. So I think this is the configuration. Okay. So this height is given as 40 centimeters. The value of area is given. The area of cross section is 0.4 meters square, and the area of opening, let us call this as small a, is given as 1 centimeter square, right? So this is 1 centimeter square. So how do we figure out the answer? Idea is very simple. We will apply Bernoulli's theorem between 2 points. Let us consider point P and point Q. Point P is just inside the opening and point Q is just outside the opening. So just inside the opening, we will have the pressure as atmospheric pressure plus mg divided by capital A plus rho gh. Okay, h की value कितनी है? The value of h is 40 centimeters. So this is the total pressure present at point P plus the kinetic energy at point P, which is half m v1 square, right? And that must be equal to total energy at point Q, which has the pressure of P naught and kinetic energy of half rho v2 square. Now, in comparison with V2, V1 will be very, very small, and hence we will be ignoring this entire quantity. Half rho V1 square will be ignored in comparison with half rho V2 square. As well as P naught cancels out from both sides of the equation. So from here, you can rearrange this equation and say that the value of V2 will be equal to root 2mg divided by rho A plus 2gh. Okay. So you now just need to put in the values in this question and get the final answer. So I think approximately the final answer of this question is 3 meters per second. So let's move forward and get the next question. This question says that the projectile motion of a particle of mass 5 gram is shown in the figure. Initial velocity of the particle is 5 root 2 meters per second, and the air resistance is assumed to be negligible. Magnitude of change in momentum between points A and B is x times 10 to the power minus 2 kg per meter per second. We need to figure out the value of x. So, idea is simple. In this case, we will first of all take the components of the velocity, initial velocity and final velocity. We know that the final velocity in magnitude is same. It has the same angle with horizontal also. So we can say that the initial momentum completely will be equal to m times u cos theta I cap plus u sine theta j cap, right? Similarly, final momentum is m times u cos theta I cap, because speed is not going to change, only the direction is going to change, minus, here you will have a minus because it is going to be in negative j direction, so u sine theta j cap. So how much is the change in momentum? Change in momentum is final minus initial momentum, which will be equal to 2m u sine theta. Okay, and we are writing down the magnitude here. So we just now have to put in the value. So the mass is 5 grams, should be converted into kilograms, times u, which is 5 root 2, and sine theta is 1 by root 2. So solving all of this will give us the final answer as 5 times 10 to the power minus 2 kg meter per second. So answer is 5. Right. So this is the end of our discussion today. So best of luck. Goodbye guys. Take care.